Morning all, and welcome to session 8 of AVD for engineering workloads. Today what we thought we'd talk about is an unusual area for VDI, an area where we have heavy workloads and demanding applications and some quite unique use cases, right? And how do we deal with them in cloud, and what's changed being able to take VDI workloads into the cloud, and how we can manipulate that and get the best use. So we've got some fairly challenging areas there, and it's an area that traditionally virtual desktop infrastructure would run away from, right? But I think we can embrace that and have some interesting solutions for that. So that's what we're going to talk about. Just a bit of a reminder to format always, please ask questions along the way. We are recording this session, so that'll be up on our website and you can access that at any point in the future. So our agenda, so yes, let's talk about CAD workloads in particular and the history of CAD workstations and the challenges that we have in IT to help engineers be able to use them effectively, right? And then we'll move to sort of CAD in the cloud and what's changed, what we can achieve there now that we've got this new paradigm, and putting virtual desktops into Azure. And then we'll show you what we can achieve out. So I think George has got a demo where we can run up some other CAD benchmarks. So a lot of these CAD tool sets obviously come with benchmarking tools because you need quite high-end graphics capabilities, etc. So we'll show you what we've got on one of our test systems. And then a bit of a demo of, I think George got a little bit of a surprise and a different angle and show you what these graphics cards can achieve when we use the power. And as well as myself as host and George as our sort of lead engineer on this series, we've invited Ian from our team. I want to say hi, Ian.
Yeah, hi everybody. Just a bit of a background on myself. As Paul's mentioned, this is an unusual session around engineering software workloads. And my background of about 25 years working in end user compute and looking after large end user compute fleets. About 12 years of that was in engineering software and running engineering packaging departments. And it's always been a tricky item in the IT world from both licensing and technical point of view. So I've been very interested to see how the virtual world has been coping with it.
Yeah, thanks, Ian. And of course, everybody probably on this series knows George by now, right? Morning, George. Yeah.
Yes, morning guys. How are you?
Good. So you got some good demos for us today, mate?
I do. I've got an interesting one towards the end, so hopefully, yeah, it'll be pretty exciting to go through. But yeah, I've got a couple benchmarks as well to showcase, and a couple of I guess some insights into how to deploy GPU machines in Azure today.
Thanks, mate. Should we move to the next slide then, mate? And we'll talk about some of the traditional challenges, right, with CAD workstations. And like I said, we brought Ian along to chip in on this story. But when we look at the sort of requirements of CAD workstations, they are not something we would normally want to put on a virtual desktop, certainly not on a multi-session one. And we'll talk about where pros and cons of multi-session a bit later on. But the issues that we often see is, and particularly in today's environment, is supply chain. Just getting that sort of power into a workstation, right, is an issue. I know right now we're waiting on even just basic laptops for our new starters at cubesys, right? So there's all sorts of supply chain issues. And I think I was speaking to a network partner this week, and he said there was up to 12 months wait time, right? So that's obviously one challenge that we've got. So if we need to add high-end compute and in sort of a physical sense to our fleet, that's a challenge, right? And often these things were custom built and need particular requirements. So the GPU cards that we needed to add to there, the specs of these machines for particular workloads, and they're all different. If we look at AutoCAD, Solidworks, Siemens NX, and a multitude of other CAD-based workloads, they often require quite different configs, and obviously when we to purchase that, we'd have to spec that up, wait for it to be custom built, and then delivered. Any comments on that, Ian? And as your sort of experience in the past there, we're trying to get that stuff to the fleet.
Yeah, there's two other things. It's another world I lived in was in a pre-COVID world, was building hybrid workspaces as well. So giving people the flexibility to work in different work scenarios and different workplaces within a building or from home. Obviously, big heavy workstations don't play to that either. So it was always a hindrance of these boxes are not only hard to get, they don't move. So you've got to pin to one place. So even in a post-COVID, where hybrid work now means working from home and the office, again, there's another challenge there. So I think it's also worth that there is, in that GPU world, there is two types of GPU customers in this world. There is the ones that need the graphics output for in the AutoCAD or the microstation worlds, and then there is the people that need GPU for compute in the modeling worlds. So they're but both of those customers tend to work in the same organizations, and they both need the same GPU cards, but they use them for very, very, very different things. And we'll talk about some other options there are for those modeling cohorts later. There are some other options as well, but yeah, they're two distinct groups.
Yeah, so I mean, look, the challenge is there then, and then if we think about putting these type of challenges into a virtual desktop, or when we think traditional infrastructure and on-prem workloads, it's next door to impossible, right? So being able to share GPUs is a new thing, and George is going to talk about a little bit about that in a moment and what we can achieve with cloud. But when we were like back on premise, being able to build anything that will go towards a virtual desktop was, for this workload, was always a big no-no in the sort of 20 years I've been doing infrastructure and virtual desktop infrastructure. It definitely was like, stay away from those workloads, because the applications are very heavy, right? They're not only heavy in the compute that they use and the memory they need and things, but also like just to install and manage them is full on, and it's quite difficult, right? And then the amount of data that they would generate is another challenge, right? So when we were thinking about virtual desktop infrastructure in the past, we would go no, and we would definitely move towards these physical solutions and bespoke things, and then we'd have the type of problems Ian's talking about there, right? Where they are immovable objects that usually sit under an engineer's desk, or maybe in a computer room that we could RDP to, but most of the time it'd be like very bespoke systems, and obviously they're expensive and they're sort of a fixed capex, which ages and then comes out of date and we need to replace them. So the whole cycle of looking after CAD workstations, the applications, the data sizes and stuff that goes with it, all of that was a huge challenge for IT, right? And our engineering friends would often get quite frustrated with IT that they couldn't move faster or move a bit more agile and better, and we couldn't really help them, to be honest. Right? It was
Paul, I think another thing, a good thing to note there as well is, I mean, you're paying for these CAD workstations that in reality are not being used 100% of the time. Like, people still do their day-to-day office workloads on them, right? So you're paying a fortune for a machine that's going to sit there, that's probably going to run a render job, you know, once, twice a week or something like that, depending on utilization. But at the end of the day, they are still going to be running their day-to-day normal, you know, office duties, Outlook, you know, web browsing, that kind of thing in the background. So
again, yeah, they're very inefficient use of that investment, right? So I think we had a client recently, that's a startup in an engineering firm, and that's exactly the case, right? They would need that high-end compute between a group of them for a few hours each per week, right? And certainly not all day, every day, right? I mean, if you invest in this type of workstations, hardware, which we had to do in the past, it's not really not a good use of capital, right? Cool. Any other comments from your history or stories, Ian, on that side before we start looking at what we can achieve in cloud?
No, I'll just reiterate, confirm some of the things you said. I can distinctly remember paying a fortune for some very bespoke network KVM switches to do this kind of thing in the 10 years ago, 8 years ago. And you could split the cost of one machine across maybe 3 people, but again, it was fixed to a desk. It had physical thin clients. This has always been a very, very messy area. And I think George's point just made, incredibly valid, is unfortunately up until the advent of modern cloud technology is that we always have to spec computers for the worst case scenario, which in this world is very expensive and is only potentially an hour a week, hour a month that you actually use its potential, but you have to put the capital up front for that 1 hour per month, which is, again, very inefficient use of cash and also resources.
So let's have a little chat then and move on to what we can achieve with Azure and what we're being able to do by being not only having GPUs available, and Azure is quite unique in what it can offer our client base, but also being able to share those GPUs, right, and work in some interesting ways. So shall we have a look at Can we move on to the next slide, George? Yeah. What can we put? Do you want to talk us through some of the options there, mate, and the technical specs of what?
Yeah, absolutely. So just before we jump into, I guess, what Azure's got to offer, I just want to take a step back. So I want to bridge the gap or the connection between buying physical laptops back in the day or physical desktops that cater for that workload to going to on-prem hypervisors, right? It wasn't until about, 8-10 years ago where VMware introduced things like NVIDIA grid components where you could pass through the actual physical video card to, virtual machines that are running in VMware Horizon or like Microsoft Remote, I think it's FX, Remote FX, where you can basically pass through a physical card either to a one-to-one mapping of a VM and then have that VM take 100% capability of that card and utilize it to its full advantage, or you could chop it up and split it across multiple VMs and use things like profiles to say, of a 8 GB video RAM card, we want a couple of machines to utilize 2 gig of it, and therefore we split it up into 4 VMs. So there are. That's where sort of the technology was going, and it was very difficult to move that into Azure Cloud because obviously we as the consumer, we don't have access to those data centers. We can't load physical cards inside those VMs, right? So this is where Azure has come in and bridged the gap, and I think Azure were one of the first ones to do this and give users the capability of adding GPU cards to some VMs. So what Azure has done is they've introduced AMD or NVIDIA type graphics cards depending on your workloads, right? Some users might prefer NVIDIA, some might prefer AMD. It's really, the choice is yours. They've got multiple different SKUs, and I'll get into some of the SKUs a little bit later. But again, what we can do from that sort of on-prem move into the cloud is we can utilize a VM for a single GPU and utilize that, for a single user or a single virtual machine and take full advantage of that card. We can add, if we wanted to, multiple GPUs to a single VM, right? So if we have additional workloads or we need really hard number crunching stuff, we can leverage 2, 3, 4 GPUs on a single VM and use that to get the job done faster. Or we can even go down to the real granular level and say, all right, we want to split a particular GPU and section that off for our particular workloads, and we don't care what happens with the other half, right? We're going to say of this particular graphics card unit, we want to chop it into 4, and we're going to take 1/4 of that workload, and that's going to be reserved for our workload. So that's sort of the granular level that you can get with some of the Azure VM GPU SKUs. Some of the workloads that you've got around, I guess engineering workloads or GPU workloads is depending on the application, and this is very important because you don't just want to spec something up for the hell of it and say, oh, this is, cost me $2,000 a month. Surely it's got to be better than the $1,000 a month version or that kind of thing, right? What you want to do as the end user is basically figure out, is it compute intensive workloads that we're going to be running? Is it graphic intensive? Or is it virtualization workloads? Some video cards are a lot better than others at doing particular workloads. And at the same time, whether you're going AMD or NVIDIA, there are also some limitations in the background in regards to licensing. Like at the bottom there, I've got an NVIDIA grid license, for example, to be eligible to run that with the lower SKU. It's either one full-blown desktop to take advantage of I think it's an M60 Tesla video card, or you can publish 25 remote apps from that particular VM, right? So you need to be wary around what you're going to be doing with it, how many users, make sure you're in license agreements, that kind of stuff. But, again, it really depends on the actual application that you're going to look at publishing. You need to do your research. You need to see what the vendor recommends. Later on in some of the slideshows, I've got a couple of examples from some vendors where they've got some of their in-house engineering team to go through and validate some use cases for customers and provide some metrics and help them to determine which graphics card or which SKU or whatnot does the best bang for buck.
So a good segue, and that's a good time, and I'll pull Ian into the conversation. So I remember working with an engineering company, and we learned quite a bit by engaging with Microsoft to make sure that we were lining up the right type of GPU and compute capability with the workload and the application type, right? And that is quite an important point. There is differences in particularly in like that rendering versus modeling, right, and the computational thing. So getting the right type of graphics card or that right type of computer number crunching capability is quite important, and it can get quite different results depending on what you use. So I'm thinking that was it the sound engineering or was it water? Ian, you have to remind me. Remember that when we engaged Microsoft to help us understand the best compute type to use.
Yeah, there was two. There was sound engineering and there was water modeling. Both of those are incredibly, anything that involves waves or things sloshing around in tubes or moving, is it in like steam or things like that, is a huge amount of compute power to analyze or predict what's going to happen. And we did work with Microsoft. We also work with the vendors. A lot of the software vendors also have multiple versions of their software depending what platform you're going to use it on. So some of them have, will even have AMD or NVIDIA based drivers or applications, or and a lot of them rely on Python as well to do a lot of the work, a lot of the modeling stuff, and a lot of them, some of them are where they might be GPU intensive, but some are processor intensive. Like the batch example we worked with was some piece of software reacted very well to us spinning up 200 machines with 2 cores and 4 gigs of RAM. That was faster than a single machine with 40 cores and 256 gigs of RAM, just by the way the software accessed those resources, and every piece of software is different. Yeah. So it's about the analysis up front. It is a lot of work. I mean, to be fair, it was the same analysis you had to do in the physical world as well, right? It's the same analysis. It's it's horses for courses in this world. It is reasonably complicated.
That's actually, that story of spinning up the 200 VMs is actually interesting, because we didn't do that with AVD, right? There's another service inside of Azure, batch. And if we're talking about modeling workloads where we don't need to interact with the application, where we can give it a data file that needs to be processed and then spit out a result, often that's better done through a DevOps pipeline and using something like Azure Batch. And what that did, it allowed us to pick a VM type with a particular type of processing capability, a graphics card, and then spin up 200 of them for like a couple of hours. And we took, for that business, what was taking them on premise in their desktops, 2 weeks to process that data. We did that in a few hours, right? 3 or 4 hours. And that was by splitting out the data workloads and spinning up like a couple of hundred VMs with that application installed, processing that data and outputting it again. There was no human interaction with that. We automated that piece, right? And then got them the result out. And that was hugely powerful for that business, because it turned what was, a week of processing or 2 weeks of processing into a few hours. So we could like turn around the result very quickly. It meant that they could rerun models if they had like queries without impacting their project timelines, right? And actually deliver the result to their client way quicker, right? So very impactful if you can leverage that capability. Right?
And that was a classic. Sorry, Joe. That was a classic of. As IT professionals, sometimes we get very stuck in the ways that we want to work and how we work. And that the reason that modeling was taking 2 weeks was the way they were doing that was running it on a fleet of laptops and desktops in the office. So they had to do it out of hours when other people weren't using them. So they were creating a neural network in the office, but they couldn't use, sometimes the network would break and other kind of things. But it's that old, if the only tool you have is a hammer, everything looks like a nail, right? So just because you've always run this on laptops, just thinking that little bit differently and moving to a DevOps concept, unlike the team we work with, were blown away by the results. But even for us, it was a learning curve. It's one of those, I'd say any desktop IT professionals is just always, this stuff forces you to think a little bit outside the square. And there are other ways of doing this. Although AVD is awesome at the job it does, sometimes you've got to go slightly outside, but there are other options in the cloud world that are a very left field where we've had some excellent results with.
Yeah, absolutely. The other thing I just wanted to add on that was, right, I mean, these guys, they've obviously got these laptops and, they had to schedule time and whatnot, right? So we're trying to gather all the workers into one room to go and do it. With the batch job, when you kick it off, right, you're only paying for the compute or the resources at the time of processing it. At the end of the job, the VMs are just deleted. And that's the power of automation, right? So we're literally using these VMs for, 4 or 5 hours to do whatever workload needs to happen. Then at the end of the day, once they're done, they'll dump their exports on a shared network share somewhere, or however the program operates, they'll spit out that result and those VMs will get deleted. And you've literally only paid for 20 VMs or 50 VMs for 4 hours worth of work, and then that's it, job done.
Yeah, that particular client was blown away by the fact it costs about $300-400 to rescue an embarrassment on a $500,000 project, and it was less than the cost of a laptop to actually solve that problem, and they were just absolutely blown away with that concept.
Yeah, we came up with that as we'd done work not too far in the past where we'd helped a cancer not-for-profit do some modelling with their application. So our mindset was like, oh, well, could we apply this to this engineering workload? And we sort of changed that and challenged ourselves to think a little bit differently. Right. So it was a good example, and we're now doing that with more engineering companies. Right. So one of the questions we ask, if you've got modelling workloads, should it be in a virtual desktop? Should it be in a desktop at all, or should it be in something like Azure Batch and use that DevOps automation process to spin up a large number of machines, do the calculation, and then shut them down again? And sometimes it's not even a large number of machines. We can put a couple of high-end computes, but still run it through that automation process. So we have to think about the difference between, those AutoCAD interactive applications versus modeling, where we have to send it off to do a bunch of calculations.
Yeah. So I've just got up on the screen here sort of the next slide around some of the Azure VM GPU SKUs. And I mean, this is straight from the Azure document, like the Microsoft Docs page, but it gives you a good indication around what you can and can't use these particular workloads for, or what they're generally good for based on, vendor specs, that kind of stuff. So, I mean, you look at the NVV4 series, which is the second last one there. They're good for VDI and remote visualization. So they offer partitioned GPU. So that's what I was saying before. Rather than paying for the cost of a full-blown GPU assigned to a single VM, you can partition this VM. You can go from 1/4, you can go half, you can take the whole video card if you want. And at the same time, it depends on, if you're going to use this with Azure Virtual Desktop, you can then use that to share that load across multiple users, because let's be honest, if there's 4 or 5 people on there, some of them will probably just be using, Office and other tools to do the day-to-day job. There might be 1 or 2 users that are on there that are going to run workloads, but, whether they're running at the same time or not, you can spec it up or spec it down as needed to cater for that. At the very top there, you got the NCV3 series. So if you're doing any like machine learning simulations, that kind of stuff like Ian was talking about, you'd probably want to look at deploying some of those VMs there to do some of those workloads, because they're just doing number crunching in the background. So we don't necessarily need it for visual output to the end user, and it's not about like low latency or frames per second or anything like that. Whereas if you wanted to do something like that, like gaming, then you'd look at the NV series, and that's what I've basically provisioned up today. More so because there are barely any resources in Azure to get a GPU VM. They're a hot topic at the moment. They're flying out like hotcakes. So the only one that I could secure was an NV series, a little bit of an older one, but it's pretty much good for remote virtualization, streaming, gaming, encoding, all of that stuff, right? So it's got DirectX support, OpenGL, etc., etc. So again, go through and have a look and see what would be the best use case, and go to your vendor's website and see. They might already have done some tests or some benchmarks around which one to go for.
One of the other things, it just reminded me, and not directly related to this, George, was another engineering company we were working with, and they were trying to set standards for how to use AutoCAD, for example, right? And my understanding is, and Ian, you might be able to educate me a bit more, having worked more directly with those engineering companies. When we set up CAD, there's often standards like the measurements and things that have to be universally used by the engineers, because you don't want, I don't know, maybe a bit silly example, but somebody working in inches and another engineer working in centimeters, and they're working on the same project, right? And so all those sort of standards within the CAD program can become quite challenging to manage. And what virtual desktops allow us to do is centralize that and make sure that we have really good profiles, and it's easier for us to assist those engineering guys by enabling those standards, right? Is that your memory of that, Ian? That was one of the other benefits of it.
Yeah. So, and something I worked on, it's like a modern version of it, but we worked on this years ago and built up like a standards-based like SOE type stuff with this, like almost like an AutoCAD SOE on top of the traditional SOE we were managing. And yeah, there's things around templates and pen sizes, and even things that you don't even think about, but even the legal statements that are in the drawings at the bottom, like you don't want to end up in a scenario where someone pours concrete against a document that has not been double triple checked yet. So there is lots of small print in those documents at the bottom. And if you use the wrong template, you're potentially putting the organization at legal risk and other such things. So they're super important to make sure everybody's working off the same set of templates, the same pen sizes, same this, same that, same layering, all that kind of stuff.
So managing that, keeping that up to date, and doing that in a dispersed, and in the old world, when we had those CAD workstations under the desk, just managing all that becomes a pain, right? Because basically what that boils down to is a set of files that need to be the same on all those workstations.
Yeah, we used to get clever and use SCCM to do it as a package and executable to put it on the right spot, but you don't know what you've not. You don't know what you've missed, right? You don't know who's not got that package and has just gone off using AutoCAD. So it was still not as foolproof as this centralized method is.
Yeah, centralizing that in a VDI makes that much easier to control, right, and keep a handle on, right? And then we allow people to remote into those VDI sessions and use the same set of standards that we know we're controlling centrally, right? And we can work with the team to do that. It's another side benefit.
Speaking of remoting into sessions, I've just got something here around, using these GPU style VMs for Azure Virtual Desktop or remote desktop access, right? So depending on where you are or what your workload is, if you are deciding to use some of these GPUs with Azure Virtual Desktop and they are something that you want to use for remote visualization, like frames, you want the frame rate to be good, decent, nice, smooth transitions, that kind of stuff, I would recommend enabling RDP short path for public or managed networks, depending on what you got set up there. But basically what this does is when the user logs in, typically what happens is the user will connect to the gateway and then be tunneled to the VM to access the session host, and then traffic will go over sort of this top line up the top here. When you turn on the RDP short path, if it's got line of sight to the virtual machine itself, it will bypass the gateway and directly connect to the VM. And that will typically, on average, what I'm saying is, if we're going via this top route up here, we're probably hitting about 20 to 30 milliseconds latency. As soon as it switches over to RDP short path, we're looking at like 4 milliseconds latency. So if you have any of those workloads that require something like that, where you want to keep nice, smooth, butter smooth transitions, definitely look at turning on RDP short path so that you get the best user experience for your users.
Yeah, good tip. Yes, particularly with those anything sort of any sort of graphical workloads, engineering or not, right? That short path really does help the performance, right, and the user experience.
Yeah, absolutely. Moving on to some of the more technical stuff as well. I mean, when you're doing any Azure GPU VMs, you need to install the graphics drivers, right? So think of it like a traditional on-prem PC. You put a graphics card in it, you go install the drivers. The same thing applies here in Azure, right? So anytime you deploy one of these VMs, whether it's AMD or NVIDIA, make sure you go in to the VM, look at the extensions, install the appropriate GPU driver extension. So that way the drivers are installed and you can take the full benefits of, I guess, the GPU VM itself. Also on that topic, a lot of people forget to apply some of the remote distance session environment policies, right? So things like use hardware graphics adapters for all desktop remote service sessions. So this is GPU accelerated like app rendering and things like that. So where we by default, you use the CPU to display graphics and things like that, but we want to take advantage of the GPU. So that's something that you need to look at enabling for your session hosts or your servers, or even if it's just a standalone box, right, that you're RDPing, you still want to enable this because this is like global to RDP connections. The next one down there, configure H.264/HVC hardware encoding for remote desktop connections. This is, again, GPU accelerated frame encoding. So some GPUs don't support this, but you need to look at, whatever SKU you're deploying, read the Microsoft docs, it'll tell you whether it's supported or not, but, you want to turn that on so that the GPU does all the frame encoding for you. And then finally, the last one there is configure full screen video encoding. That talks about prioritizing H.264 graphics mode for remote desktop connection. So when you turn that on, it's going to do the full screen encoding, so you get a better experience for your end users. And there's obviously a whole bunch of other stuff there, like remove disconnect option from shutdown dialog, that kind of thing. So if you have workloads that need to to run. I mean, this is more so going into just your general group policy settings, log off, remove start menu, that kind of stuff. But when you start looking at things like remove disconnect option from shutdown dialog, some applications themselves, when you disconnect or when you close a session, they probably stop running the render job or that kind of thing, or maybe you need it to run for X amount of days. There might be a long job that processes. You want to turn off timeouts and disconnect session limits and that kind of stuff so that the actual job itself will go ahead and finish running as intended, or whenever it finishes.
What you're saying, George, is that we're always important to make sure that we get the GPUs optimized for AVD when we're doing that.
Yep.
When we get to GPU workloads, there's an extra level there, right? So we have to take a bit more care about making sure that those settings are optimized to get the best performance. But we're
absolutely
paying extra hardware that's designed to get a better user experience. It's also important to get the configuration right to match that. Right?
Yeah, 100%. You have to turn these on. I mean, these are things that once they're turned on, you'll see a massive difference in what's going on. And there's a lot of videos out there on YouTube where you go to like web pages that do like aquarium rendering, smoke test, that kind of stuff, like Ian was talking about. So a lot of the physics stuff that's really intensive on the way the water falls or the way the smoke goes around, that kind of stuff. So as soon as you turn these on, you see like a massive increase in frames per second. There's no more choppiness, there's no more latency, that kind of stuff. So definitely look at turning some of those options on. One other thing that I wanted to jump in and just mention was VM start on connect. Now this can be applied to both AVD session hosts as well as standalone like servers that you're deploying in your environment to run workloads. But I wanted to cover this because a lot of people tend to log into a VM, do their workload, and then just disconnect. And then what happens there is the actual VM is going to be running in the background. GPU VMs are very expensive. We're talking like minimum $1,500 a month to run some of these VMs, right? And if it's just going to be sitting there doing nothing, it's just chewing away cash for nothing. So I want to highlight this. AVD has got VM start on connect, where as soon as a user goes to connect to a VM and it's powered off, if they want to go in there and run their GPU intensive workload, they can double click their machine, and I've got there in the top right where it says starting remote PC. So it's not until I actually, as the end user, go in and double click that VM, that's when it's actually going to boot up in Azure and it's going to give me access into it. Now, I would typically go in there and run whatever workload I need. And then once it's done, depending on how many scripts or automation I've got in my environment, but if there was something in there to go and power off the VM once it's finished running its workload, or if I give the user the ability to shut down their own VM, as I've got in the lower left screenshot there, so they run their workload, they power off the VM, that VM itself is still it's allocated. So we want to deallocate it in Azure to like essentially release that VM and stop all of those costs. So what I do for some of my customers that run these type of workloads is I just run that PowerShell script in the bottom right there. So I've just taken a small snippet of it for this example, but basically we're going to go through and run this, on a schedule using an Azure automation account and have it go through and check, is the VM stopped every 15 minutes? If the VM is stopped, but it's not deallocated, well, then go ahead and deallocate the VM so that we release it and we're no longer being charged for those high-end workloads. And with this kind of stuff, you typically put it on the resource group where that contains all of your GPU VMs, and just have it constantly monitoring and scanning so that, if any of your engineers are doing workloads, they forget to power off their VM or they shut it down, but it's not deallocated in Azure, this will go and sort that out for them.
So I suppose what you're saying, George, is I should probably quote, I think it's Spider-Man, isn't it? With great responsibility, or with great power comes great responsibility, right? And so we need to control costs, right? So we are paying more for these workloads, and we need to be proactive in cost management. Otherwise, they can blow out quite easily. So I think the cost model, if you look at it from a business level, is often quite attractive if it's well managed, right?
Yep.
And that being careful about how we use that extra workload, right?
Absolutely. Yep. Look, I mean, I myself am not an engineer. I don't know how to use AutoCAD any of these sort of high-end compute workstations, right? I don't know if they're running optimal. So you also do need to speak to your users and see what's going on. Like, is the performance on par with what a laptop does? Can we put an extra user on there and utilize maybe Windows 10 multi-session, right? If we're doing GPU-related workloads, maybe we can chop up that card between 2 users on the same box. Or if that's not the case and we're doing CPU-intensive workloads, we need to ensure that our users are getting the best bang for buck. Maybe have, like Ian said earlier, maybe having 40 cores, the application doesn't like it. The operating system might see the 40 cores, but the application won't utilize all 40 cores. So we're using money, we're paying money for nothing when we can just use a 4-core VM to do the same thing. But if we have multiple 4-core VMs, we might get the job done a lot faster if the application supports it. So again, you just need to go back and make sure that your end users are actually seeing an improvement in the long run. One thing I wanted to quickly cover is fair share technology. Now, this is something that is enabled by default on RDS environments. So down the bottom there, it applies to Server 2016, Server 2012 R2, Windows 10, and Windows 11 multi-session environments, right? So anything that's running RDS, fair share technology is used to balance CPU, disk, and network bandwidth resources among multiple remote desktop sessions. So what this means is, when there are multiple users on a session host, Windows by default is meant to give everyone a fair go around CPU resources or disk or network. So if we have workloads that are very CPU intensive and one user kicks off a job and it's smashing 100% of the CPU, this is meant to bring that resource down for that particular user and sort of half the CPU usage so that no other users are affected. In my testing, I find that this doesn't really work. There are applications out there that will just smash the CPU, and I've never really seen this technology work, but I do want to mention that it's there, and it might be a particular use case. Maybe it's something I've done wrong in the past, but there is something there by default from Microsoft that's meant to give everyone a fair go around what's going on. There are other vendors out there like Citrix that does this very well, but it's a third part. It's an additional licensing component. And I think you can only run it in Citrix, for example. But I know that kind of stuff you can say, each user gets 20% of the CPU and that's it. And that's a hard limit. Whereas this will sort of attempt to try and balance that out across. So if you have a job that's running one thread and that thread finishes, the next one goes to run up, it might keep spiking the CPU up to 100%. But yeah, just wanted to mention that.
The comment you made earlier was that we've got to be really careful and talk to the users about what the application needs and what the workloads are. So I was only certain applications I think would recommend multi-session for when we're talking about these high-end workloads. Sometimes you need a one-to-one mapping to be able to get the right result, right? So it is really, and obviously AVD does both, but and the reason we want to go down multi-session is ease of management and cost benefits, right? So we've got to balance that against the user experience and make sure it's right.
Yes, absolutely. Here's a really great example that I found from ArcGIS Pro. So we had a customer that was looking to run ArcGIS workloads, so like ArcGIS map and etc. inside an AVD session host. I came across this article. It was at the time recent, February 16, 2022. I mean, still recent there. But Ryan, he's an Esri performance engineer. He's basically gone ahead and created a blog article and done some testing around different sized or skewed VMs. And in the end, his conclusion was, using AVD is a solid option to deliver ArcGIS Pro to several users on a single VM. So we're talking multi-session here. This can provide the added benefit to help control cloud cost. When used properly and with a solid cloud use strategy, you can deliver ArcGIS Pro to more users leveraging Azure Virtual Desktop. So these guys have gone ahead, they've validated, they've tested different type SKUs, different type VMs, and determined that this particular one here, with no more than say 5 users on it, is cost effective and does the job, and it's on par with whatever hardware they were comparing it to. So definitely look at vendor recommendations.
Blog post making it into the wild, because I suppose traditionally on a lot of what we see is, particularly from the vendors, still is giving you hardware specs, and we want to move away from that and be able to use these virtual desktops because they're much more flexible and can be much more cost effective if they're used well, right? So it's easy to see that sort of stuff out there in the wild. Nice find.
Yep. Cool. That brings me on to my demo. So I've got two things to show you all.
So maybe while you're bringing that up, George, I might just mention to the people on the call that obviously George is about to show you some of the power of GPU and the benchmarks, but we're actually doing this over Teams as well. So it'll be interesting to see what the experience is like for us at the other end of Teams and what you get to see there, George.
Yep. I can tell you on my side, it's pretty smooth, and you'll probably see in one of the examples just how smooth it is. I'm able to play a game on it. So yeah, let's see how it goes in the demo land. So here I am connecting to a GPU Windows 10 VM. Actually, while I log into that, if I go, I'll just show you the size and the view of the VM that I'm running. So this is it here, GPU 0. It's actually a NV6 promo, so that's all that I could get at the time. Leading up to this, like I said, if you're going to do any GPU stuff, you need to get in early and log a support ticket so that Microsoft allocate those resources to you, because they're a hot topic at the moment. So that's what I'm running. 6 cores, 56 gig of RAM, and it's basically got an NVIDIA M60 Tesla video card attached to it. So I've just logged in. If we look at the task manager, we go over to performance, I can see NVIDIA Tesla M60 has been attached. We'll go over to computer management. If you look at device manager, I think it's here, there it is, NVIDIA Tesla M60. So it's been installed, it's been configured. As I mentioned earlier, you need to make sure that, one, you've got the drivers on there. So I've actually got the NVIDIA control, like as part of the driver installation for this particular NVIDIA model, installs the drivers, the control panel, the grid licensing, all of that stuff, right? And then at the same time, you need to ensure that under your remote desktop services group policy object, you need to ensure that you've configured all of the group policies to ensure that, you know, it's going to use full screen encoding, hardware offloading, etc. And then we've got the drivers here that talk about the M60 Tesla. So first demo I want to show you. I've got AutoCAD on here as well. I don't know how to use it, unfortunately. I tried to download a couple of demos, but I wasn't really going anywhere. So Plan B, Heaven Benchmark. This is a benchmarking software that gamers tend to use for frames per second and that kind of stuff. So I've got Fraps running down the bottom here. Fraps is a like a frames per second tool that overlays over the top of what you're doing to tell you how many frames per second you're actually getting. And then with this configuration, you know, you can select what DirectX version you want to run, your quality, that kind of stuff. But I'm just going to leave it all default, so it's running at a high quality. I'm not going to go ultra because I don't think this card will probably handle it. But let's just give it a go. Let's see what happens. Obviously, in Azure, the higher the SKU you go, the bigger the GPU you get, the more resources you get, etc. But let's see what happens here. So in the top left, we're getting 0 frames per second at the moment. Actually, I'm not sure if you guys can hear the audio.
Not getting the audio. Graphics look surprisingly smooth, because considering we're over Teams, that's pretty good.
Yeah. Let me
I was expecting Teams to bulk that, but it looks pretty good.
Let me just reshare with the audio, just so that it's a little bit more immersive for you. Hang on a second.
So these benchmarks for the gaming things, they really sort of push the GPU. So you're to get that back to a sort of CAD type workload, George.
Sorry, can you hear me now? Can you hear the music?
Yep.
Cool. Sorry, you were saying, Paul?
How would we? So these gaming benchmarks is really just pushing the graphics card as hard as it can.
Yeah, that's exactly what these benchmarks are doing. I mean, so if I can get Task Manager to show up here, which I can't, they're just basically going through and just rendering stuff on the fly, you know, making sure that the video cards work, is how many frames per second you can get. I mean, but at the same time, whether this was a an AutoCAD workload or whatnot, I'm pretty sure with these sort of visualization workloads, I mean, I'm able to play games on here that want low latency, that want to, you know, have butter smooth graphics for the end user, that kind of thing.
Using CAD software, George, your excuse is to go and install some games. Then is that the?
Yeah, pretty much. Yes. I'm not a CAD user, so I'm not sure. But there you go. That was the Heaven benchmark software. If I can grab the taskbar here, you can probably just catch the CPU going. Actually, no, the metrics are bad. But I mean, you know, you typically see the CPU going up through the roof. And that doesn't just apply to this. I mean, if I was to jump on YouTube, play 4K videos, that kind of stuff, you'll see the GPU being used. Moving on to the more funner example, I've put MotoGP on here. Originally, when I first did this, I had the Microsoft Flight Simulator on there. But I just thought it's a bit boring. It's a bit slow. So it didn't really showcase off the graphics or the frames per second anyway. So I thought a good car racing game or motorbike racing with, you know, fast frames per second would be a lot better. So let me spin this up and I'll show you that this is actually playable.
And assuming you've got some sort of gaming rig at home, then George, how does this compare? Maybe
it's
we're targeting the wrong customers. Maybe we shouldn't be talking to engineers. Maybe we should be talking to.
Yeah, maybe. Honestly, it's really smooth on my side. I'll get to the actually while I'm here, check it out. So I've enabled RDP short path for this particular one. So this is on a public network, and you can have a look at the round trip time, 5 milliseconds. Look at my available bandwidth. I've got 70 megabits to play with. My frames per second through this session right now is 30 frames per second. Typically games, I mean, for it to be smooth, you want at least 30, right? So we're over that. And at the same time, I think we should see fraps pop up. Oops. We should see fraps pop up here in a sec when I kick this game off, but let's just go no Grand Prix. I tried to play this game before and it was raining, so I kept falling off the motorbike. So it's like a really good simulation.
Greetings to all of you watching out there. We're live again from the Algarve Internet. The mechanics take the bike out of the pit.
So it's just putting me onto the track. It's in autopilot mode at the moment. So now I've got control of the bike and I'm not going to be terrible at this, but this game is really, really playable. Like the responsiveness, the keyboard controls, everything is not as smooth on my end. I'm not sure how that's coming through the team session, but it is really, really, really smooth.
Surprisingly good, actually.
It's a tad loud, but other than that, it's good.
Maybe we'll pause there, George, because the audio is a bit loud. But I think what you're showing there is pretty impressive graphics capabilities, right? And you might not be an AutoCAD expert, but games do also push those graphics cards pretty significantly. It's interesting demo, and really surprised how well that worked over Teams.
Yeah, really good stuff.
Yeah, no, that's good.
Well, look, our time is over time as usual in our sessions, but that's good. Anything else, George, you want to wrap up with, or Ian, any comments?
I just had some commentaries. One thing we've not touched on, which is also a bit of a challenge for the cloud world, is licensing. So just be mindful again, as with the software research. I remember some of the software we were using was early software. 2Flow is a big flow modeling software. They have multiple versions for different kinds of virtual environments and different kind of graphics flow. And QGIS, which is an open source version of ArcGIS. very similar. Has different versions for different suitability for graphics versus CPU version versus a GPU version. But the licensing, the whole industry, the software is made. You got the AutoCAD's big organizations, they've got network licensing, they've had them for years. When you go into some of the smaller, more specific pieces of software, they tend to be small software houses, and because the products are $5,000-$10,000 each, they use USB hardware locks. There is some network hardware locks available, and there isn't USB devices where you can network share a hard lock. But we've just done a recent piece of work with the customer where we actually go and talk to the vendor, and the vendor said we are actually working on a cloud-based network lock if you want to try that, even though their website says you have to have a USB key, which obviously kills AVD at all. So the network USB locks can work on a LAN, but in a hybrid working from home cloud environment, they don't solve that problem. So just be mindful of that before you spend too much time burning on working out with the software work. Just check off a couple of licensing questions first, because the licensing will kill it. These, like I say, can be $10,000 upwards pieces of software, and they take their licensing control incredibly seriously. So just double check that. Good point.
Cool. Anything else, guys, before we call it a wrap? Right. And let George get back to his hard work on that GP. It looks like you need to practice a little bit more, mate, I think.
I might go and get the Xbox controller and connect it up and have a proper gaming session.
All right.
Awesome.
Yes, thanks, guys. Time, and we'll call it a wrap.